agenda will be to understand what time series is, why do we use it, and moreover, like what are the flaws of time series, like traditional models time series which is there. So what are the flaws which is there in those, and for which we like why do we have Chronos over here? See, so let's directly go with a time series. So what is time series like? I believe you might have already aware of. So time series is mostly like you have, let's say, sequential data or like pattern which is there in a data. So mostly in case of, let's say, example, if I take a traditional model like ARIMA or kind of these, so or profit or something like that. So if we use these kinds of models to predict the next, let's say there are, you have data which is of 100 time stamps, and you want next 15 data to be predicted. So mostly we use traditional models like ARIMA, profit and all to just get the next data which is there. So or we make we take advantage of like RNN or LSTM. So we get dependencies on previous data which is there. So these are some things which is there in time series, but there are some challenges which is there in time series as well. Like let's say if you become, let's say, even if we use LSTM, which actually takes advantage of like it remembers for the longer period of time, but still if the data we have is like literally too much, let's say example in case of prediction of stock prices, right, or weather pattern, I think LSTM works fine. But in case of stock prices, or let's say in case of you are having some kind of website where you want to have uh, you want to know about like your CPU uses, or let's say what is your RAM and uses are there on, and how based on user, if user grows, how your data system will behave. So if you want to do these things, so in case of that, LSTM gives like LSTM, even LSTM fades over there, like the percentage that, or accuracy that LSTM produce, it is not like that much higher. So there are some errors which may come in even in LSTM. So there, because of this long-term dependencies, we have some challenges even in deep learning kind of networks, which is there. Then there are, of course, pattern cannot be like followed each and every time. There will be pattern where there will be like in your whole data, there will be some places where the pattern is not even followed. So that irregular patterns which is there in your data may fall apart your like whatever the model that you are using. So for that, like to just avoid those things, um, Chronos came into this, and Chronos is actually developed a kind of a framework which is developed by Amazon Research Labs. So they actually try to overcome the challenges which were faced in the previous like traditional time series models. So now let's start with how Chronos works and why it is going to be like the future of time series. And not only Chronos, there of course will be a lot of more models which will come based on Chronos, which will become any soon. It will become a future of it. Like how we do the time series prediction. So in case of Chronos, what it does is try to tokenize. Let's say what we have some. Just 1 second. There is. So in Chronos, what happens is it first, whatever the time series data we have, it first tokenize those data, and after tokenizing, it converts those. So whatever the time series data you have, so all the timestamps data will be converted into a discrete tokens. We'll talk about more why how tokenization is possible in time series. Usually, we see tokenization possible in like NLP, right? If we have language models, we see that tokenization is possible because we can break the words into multiple chunks. But in case of time series, how can we do that? That also we'll see, and they have actually explained it in very crystal clear way on their research paper. So, and then Chronos uses their own data set. So they have their own data set where they have a plenty of data. I guess they it starts from 8 million parameters to around 700 or 800 million parameters that is there present in their databases. Okay, so we'll see all those things later, but for now, let's just focus on how Chronos works and how it can be the future of time series. So and this is also zero sort learning. So zero sort learning basically means it predicts outcome even if the data is not seen. So that is what our goal is. But we'll see what is the meaning of zero sort in case of Chronos. Like, what does it do in this model? Now, let's see how tokenization works. So, let's say you have historical data which is there. Whatever the historical data can be anything. Let's say it can be of sales, it can be of your growth, how much your revenue has been generated till this day, right? Can be of stock prices, can be of anything. So, whatever the data we have, what it does is it first do the sampling. Scaling. So scaling is a part of pre-processing, we can say. So in scaling also we do mean scaling. So what is mean scaling? By the name mean, it takes the average of each and every. Let's say there is a it will tokenization. It will just take a time frame. Let's say out of 100, it will take a time frame of 5 data, and then it will try to scale those down to zeros, like 0 to 1 kind of thing. The minute it starts scaling those things, it will become, so in the second step, you can say, it will become more and more clear patterns will be there. Okay, like there is in the previous data we had so much variance over here. So after mean scaling, it just got into some regular pattern, you can say, like this pattern has been repeated one more time over here, the same pattern has been repeated one more time over here. So these patterns which is being seen, again it goes to a process again, that is a part of pre-processing, that is called quantization, that Chronos do in the backend. So this is the part where how does in backend it do the things. So then it quantize those time series data into number format. Like it will, let's say if we are having some kind of data over here, so it will just give it some numbers to it. So these context tokens are the numbers given to each and every data. Or usually what it does is not only numbers, you can see in this the context to obtain a sequence of tokens. So it just create a sequence of tokens which is there. So these are called context tokens. And then the context tokens that has been generated will be fed up into training part, where it will try to train those data. While training, so this time series language model, just focus on this part where it is saying time series language model. So how this Chronos works is it is actually taking advantage of LLM as well as this time series models which is there. In case of LLM, it is very much like the accuracy of each and every prediction is too much higher. If you have seen like Chat GPT kind of thing, actually GPT, there is a model called GPT TS, that is time series for GPT. So these things actually works as in like each and every time frame is converted back into a tokens which acts as a language model. Okay, like which acts as a like single word, you can say. Then it fed up into predicted probabilities. This is kind of a phase where it has to predict the next number. What can be the next number of the same? So the next number of from this it got, let's say, 2350, and then it will go to inference. In case of inference, and there is something called cross entropy loss as well. So this cross entropy loss is something like, let's say, if you have got the maximum value and you got the minimum value and you got the median value. So in case of this Chronos, it gets generates three types of value. One is mean, the median, and sorry, mean, maximum, and minimum. Okay, so these three values it generates, and then it tries to get a more accurate value out of those things. Okay, so that is what this cross entropy loss denotes here. Then during inference, what it does is whatever the data it has generated using this time series model, now it tries to, let's say, these are the data, next data that it has generated, like the three next data. So these tokens will be now dequantized, you can say, dequantized into a format of these graphs which is there. Okay, and now then we can just predict, okay, what kind of prediction we are going to get. So mostly we'll see again, like this Chronos, let's say if we are using a traditional time series data, it on paper will try to see how they have compared it. So Chronos actually gives has a error of 0.5 compared to a traditional model which has uh, error of even 0.9 as well. So these things has been rectified in Chronos model framework over here. Now let's see, in case of traditional time series model, what happens, and versus Chronos, what is there. So in traditional time series data, it relies on statistical methods which is there, right? You have to use a lot of statistics to actually create a kind of model where, and the uh, I cannot say like the worst part, but even I have done it. Like you have to work on those models. Let's say if you are changing the data, again you have to feed the new data to train that model into to get started with the new data prediction. So these are some problems which is there in time traditional time series data models. Yeah, the last point required handcrafted models and tuning for each time series dataset. So that is what we require when we use like traditional time series data like LSTM or XGBoost, RIMA, Profit, or something like this. If we use these things, we have to do it all by ourselves. But in case of Cronus, what happens is it is a automated learning. Like it has automatically, like it already have some data which or data set which is already there with them. So as I said, they have around a data set which is very large, which has a parameter of around 800 million or something. So they already have a data set where they like whatever the public data set is there available across the time frame, they already have those data set implemented into it. Yes, it will take a lot of time. The cons of Chronos can be it will take a lot of time to just do training part, but after you're done with the training, it will take a lot less time to predict a new thing. Second thing is no feature engineering required here. So automatically learns temporal patterns and structures without needing manual feature extraction. So what it does is, in case of traditional time series model, we have to actually there has to be some patterns. It has to identify the patterns. But in case of Chronos, what it does is it tries to mask the, let's say, if there are 100 data set again, and out of this 100 it will first train on, let's say, 10 data set, and out next 5 data set it will try to mask it and then try to predict those next 5. In the training itself it does that. While training the data itself, again it will predict next sorry it again it will give the output based on the next 10 to 20 data set. Again it will try to predict next 5 data set values. So based on this, what is happening from the start, while training itself, it is trying to predict and get better and better while you done with your time series, like while you have done with your training of this time series model. So Chronos is does helps us in doing these things, like how ChatGPT does it, right? Let's say it does not just give predicts a whole paragraph at the first place, right? It's try to predict each and every letter, or you can say word, based on the input that you are giving to them. So that is how Chronos even take advantage of LLM, and it tries to work on that. Next thing, advantages of Chronos will can be like combines anomaly detection and forecasting, uh, handles massive data sets, so it is already trained on massive data sets. And again, I said, if you have a data set which is too much, it will take a lot of time, of course, to train on. But the minute the training is over, it will, so you can say, supports zero shot learning for diverse time series tasks. So it will take a very less time to predict the next series which is there. So these are some advantages of Chronos which is there. Now, before we move on to this key methodologies, let me just try to share their own research paper which they have published. So, let me just try. Is this visible? I can't see myself. Let me know if my screen is visible.
It's loading.
Okay, is it
Not clearly visible.
clearly visible or not even visible?
Not even visible. There is a black screen coming.
Okay, let me just do one thing. Present my whole screen. Now it is visible, right? Yeah, so let's just try to see it. See, this is the paper published by this Chronos developers. So, like, not the developers, but the researchers, we can say. So, now let's just see one. Somewhere there is one thing that I needed to show. Yeah, there is. No, not this. Yep. So here, there is this benchmark that they have tried to, like, based on results that a model can generate, they have tried to compare it with Chronos. So we have, let's say, just a second. So Chronos is there in the Hugging Face actually. So on Hugging Face, we can see we have different types of models. First one is Tiny, which supports only 8 millions of parameters. And then we have Mini, which is having 20 million of parameters. We have Small, which is having 46 million of parameters. Then, so these are the parameters which is there, and of course, the large will be the most efficient one. So we'll see over here in the paper as well that large being the most efficient framework which is there. Then we have base, then mini, and a small is less accurate than the patch TST model. But if we see this in like this is based on average relative WQL, this and this is MASC error, like based on the relative MASC. So in this case, this all Chronos gets more uh, like it gives you the more accurate result, we can say. And also you can see somewhere, like say these things which is there, right? Even this GPT-4 TS that I talked about before, it even this is having the error of 0.87, right? If you see Arima, that leave Arima, there is this auto Arima which is having error of 0.941, right? Sorry, that's not the error, but the accuracy, you can say. And not accuracy, error, sorry. So these are the comparison between the models which is there, and based on the numbers that is there. So if we use some naive approach, it will of course will not be that much efficient. So for naive, it will always be, errors will always be there. But if you see Chronos large or even a small one, that we are going to see the demo on a small one, so even that has a prediction level of quite like good prediction level over here. So if you want, you can actually go through these like I'll just try to put it in this chat box. So if you guys want, you can actually try to go through this and get the idea, basic idea of how it works. And we have a lot of things over here. Like, yeah, so you can see based on model size how they have compared each and every models over here again. So, key methodologies that we have already talked, we have tokenization, then we have pre-trained model where we just need to fine tune our data set over there. Then we have self-supervised learning. So it just, we talked about this mask token. So leverages mask token prediction for better accuracy. So mask token is nothing but, as I said, let's say if there are 100 data set, it will first train on 10 and then predict on next 5, so something like that. And we have zero for forecasting. So what does forecasting basically means is, let's say if you give a new data set to the model. So if, like, I'm not talking about the new data set that is not at all related with your data set that you have trained on, but if the data set is on which you have trained on, if you are giving the new data set of the same, it will try to predict a more accurate value, it will try to give you more accurate value based on that. Okay, so let's just see some examples of it, like how it works. So I am already having, I have already compiled these programs, which is already there on their Hugging Face website. Like, but there is one more model that I will, like, there is one more data set that I am having that I'll try to execute on. So here we are using this Chronos T5, a small one. Okay. So what? Yeah, one more thing to remember over here is the minute you are trying to run this Chronos, it needs GPU. Without GPU, only on CPU it cannot work. So to use GPU, you need to go here on runtime, and this is change runtime type you have to do, and try to utilize this T4 GPU. If you don't use a GPU, you will not be able to execute this program. So usually on collab also, it just the first will be selected by default will be CPU, but we need T4 GPU to be selected to run this program as well. Then after that, whatever the, you have to first select what kind of model you want to select. So as of now, I've selected this T5 small. If you want, you can select out of these whatever you want to select. Let's say large, base, small. So whatever you want to select, you can select these models. Okay, of course accuracy will be different based on the model that you are selecting. And then after that, you also need to do one thing, that go to your secret keys here and create okay, here I have not I guess. So go to your Hugging Face website on profile and go to this access key tokens. Okay, and try to generate a new access key, and then whatever the access key you have generated, just paste it over here in this secret keys. Okay, so then only it will try to execute it, you can say. And then we have this data set that is there. It is just air passengers, which is provided by Amazon itself. And then we have something program, and see here there is a pattern in this data. You can see there is a pattern which is getting followed over here. So now what is happening, this 80% prediction interval, you can see last there is this 20% of the data that it has predicted. Not actually 20, not quite 20%, but it, whatever the data it has predicted, it is more accurate, you can say, over here, while it has been predicted for this 20 timestamp, I can say, right? So this is how Chronos dataset works. So this is basically to predict how many passengers will be there on, like, I guess, per what is it? Just a second. Yeah. So how many passengers traveled, something like that. It is there. So this is how it is predict. This Chronos will be predicting. Let me just go with the new, like, another data set over here. So this is again using this T5 small. Okay, So let's just see. Okay. So leaving these parts. So I'm having some sales data over here over the period of like 2, 3, 4 months, or I guess, sorry, over the period of 1 year. I'm having some sales data over here. So now it will try to predict like the sales growth of next 2 months, like sorry, next 25 intervals. Okay, so you can see here this thing just uploaded some sales data, and based on this we are getting some data over here. So this data is of like the gap of this in between these data is around 1 week. Gap is there. Now let's just see this. So forecast length is 12. I have selected over here. So it is the next 12 data it is going to forecast on the next 12 timestamp, you can say. And the interval, as we have seen in the data set, it was 7 days. So we are just putting it as 7 days so that we get the accurate result over here. So if we see this forecast chart, you can see this is how our sales data looks like. So this is, you can see it is for actually 2 years. So this is how our forecast data looks like when we sorry, not forecast but the historical data. Okay, now we have here this side we have a forecast data. So these forecast data, you can see this middle line is actually the median data, you can say, and the orange line is the high data, like high prediction, that is. So this is kind of a range that is given over here. So this is a range in which we are trying to predict. Oh, sorry. uh, how to Yeah. So this is kind of a range that we are predicting it. So in this range, you can see the median is the most perfect one over here, right? Now what we're trying to do is we are trying to just so we are having two set of data. One is the sample data that we had, and one is the actual data which is there. So this sample data, this in this actual data, there is, I guess, around 1 month of new data that we have added over here. So let's try to see how it is for like how it is predicted on sample data, and how our model is working. So you can see our sample data which is there. So this is actual predicts. This is actual data which is there. Now let's see the prediction over here. Okay, in this time frame. So this is actual data which has been there in these months, and our model, what we have got here, it is more, like we can say it is literally more accurate, because you can see there was a range that we have got here, and the actual data is also inside the same range, and it is quite matching with the median level of data that is there. Okay, so the rate of error is quite low in case of Chronos compared with other time series data which is there, right? So let's see the rate of error over here. So we can see the rate of error, what in case of low variance it was around -4 and all. In case of median it was 0. 0.5, which is plus 0. 0.5. So it was more accurate kind of thing, like in case of median. And if we see the high, so it is more like it is literally too high, so we cannot get the real prediction. So median, that is why in Chronos it takes these three things and takes the median of those, and this median is more accurate than other these two that is there. So this is what Chronos framework is, which is there on time series prediction. So